In the last lecture, we have learned about two encoding scheme, the binary encoding and real value encoding. Today, we are going to learn other two encoding scheme, namely order encoding and tree encoding. So, the order encoding can be better understood with an example. So, I want to give one example. This example is cited from the famous problem, it is called the traveling salesman problem. So, in the traveling salesman problem, the problem is defined like this: there are n number of cities and some cities are connected to other some cities. So, that one travelers he can travel from one city to another, and so for the traveling from a city to another city there is a cost involved. So, the problem is to find a path or a route that the traveler should follow, so that he will incur minimum cost of traveling, but the constant is that he should travel all the cities, but exactly once, and he should return to the starting city at the end. So, this is the problem, and this problem is called traveling salesman problem, and famously it is called the TSP. And in the TSP, this figure shows basically a simple way of representing the different cities. So, that location of the different cities on the surface of the earth, and one path that it is a one tour rather, okay, we can say one tour for a travelers is shown here, say this is a tour. So, if there are n cities are there, then essentially we have 2 to the power n different tours are possible. That means, there are 2 to the power n number of solutions are possible, and out of these 2 to the power n number of solutions, we have to search for the optimum tour in the sense that the tour which require minimum cost for the traveler. Now, this is the problem, and optimization problem also a little bit understood. So, now let us see how this optimization problem can be defined and then corresponding its encoding. So, here is the idea about how the optimization problem can be expressed. That is fine. So far the optimization problem is concerned, the input is we have given the different cities and the cost of traveling from one city to another. So, this is the input that is given, and also it is to mention that which is the starting city. Then objective function is basically to find a tour, or rather we can say a cycle covering all the cities exactly once except the first cities and with a minimum cost involved. And the constant in this problem are all cities must be visited, and there will be only one occurrence of each city. That means, he should not visit the same city more than once except the starting city. And here design parameter we can consider about if the location of the cities are given, and then Euclidean distance between the two cities can be taken as the cost. Otherwise, it is if it is specified explicitly that what is the cost of traveling from one city to another, and then this problem can be stated in terms of mathematical representation. It is like this. So, this is basically the input. This input say, okay, here this problem is simplified for 5 cities. The cities are termed as A, B, C, D, E, and then is the cost of traveling from city C to city D. It is basically is a unit is 3 likewise, and if there is no path from one city to another, then the cost of traveling is a very large. So, it is infinite. For example, so from city A to city C there is no path. So, here this is the same representation which is shown in the form of a matrix. It is written there, from city A to city C we do not find any path. That means, we can say that this is a cost of is huge or infinite cost like this. So, the idea is that if this is essentially the pictorial description of the city map, and the same concept it is stored here in the form of a matrix. So, this basically the input to the problem, it is a cost matrix like this one. Now, having this is the problem statement, we can define one encoding scheme like, so order, that means what are the different possible ordering that it can have. Now, regarding this ordering, as a simple example, okay, fine. First, before going to this ordering scheme, again let us first little bit explain about the objective function. Here the objective function is defined using this formula. Here d the distance from any city C I to C I plus 1, and if we at any instant, so this is basically the at any instant, this is the solution, where the solution is that the traveler first start with C 0, then C 1, then the city in sequence. So, this is basically ordering of the different cities are there, and then if this is the solution, then we can evaluate the cost of this using this formula. So, C 0 to C I, what is the distance, then C 1 to C 2, then C 2 to C 3, these are the, so sum of all distance, and then the finally C n minus 1 to C 0, because he has to return to the starting city then. So, this is the distance of covering from n minus 1 to this one. Now, so if this is the one solution, and then we can obtain the cost of this solution. So, here encoding scheme, this is the encoding scheme that we have followed. It basically the sequence of visiting the cities. So, sequence means if city A is first, then city D, then city B, then city C. So, it is A, D, C, B like this. So, it is the different sequence are there. Now, so this way we can encode it, and this is the major concept, the main concept in the order sequencing. So, this is pretty simple actually. So, what are the different sequence it is possible, and then that is the order encoding scheme. Now, after this order encoding scheme, we will discuss about another encoding scheme, it is called the tree encoding scheme. Now, the concept of tree encoding scheme, it follows the concept of tree. In these slides I have shown one tree. Here A is basically starting node, and from A there will be two what is called the child, the B and C. Similarly, C being the node, it has two children E and F. For the E only one children, it is called the right children, and there is no left children. For B similarly, it has left children, no right children. So, it is a typical form of tree, and here we can note that one parent here has at most two children. So, it is in some sense it is called the binary tree. Now, having this is a binary tree, it has basically representation of certain what is called the way of storing the data. If all the values in this node represent some symbols or data, for example, A, B, C, D in this case, then in the order they will be visited, it basically called one sequence or one encoding. Now, I have mentioned three different way the tree can be visited, and the first method is called in order. So, first we will visit. So, in order means to visit these things we have to visit this thing first, then we will visit this one, and then we will visit this one. Again the same way, to visit this one we have to visit this one, then visit this one, then this one, likewise. So, if we follow the same procedure, same policy for each, then the visiting will be there, and then it will be listed. For example, so if we consider the visit that okay, we will visit these things first, then this thing, and then these things. So, visit this one, then this one, and then this one, it is called the one sort of visiting, and this is one sort of encoding in fact. Now, for using this one, so the idea it is that we will visit, in order to visit the tree we have to visit this one, to visit this tree we have to visit this one. So, first D is visited, then we have to visit this one, it is empty. So, nothing to mention here. So, then next V. So, this completes the visit. So, this visit is basically D and B. So, it is basically the left tree is visited first, left part is visited, then we visit this one. So, it is A, then the right part will be visited. Again visiting right part means we have to visit this one. Now, visiting this part means, so it is empty, so no need to go there. So, we will visit E, then G. So, basically E and G. So, visiting this one, then we will visit C. So, it is C, and then finally, the F will be visited. So, this is the order. So, it is called the in order traversals. Now, similarly, pre order traversal means we will visit this one first, then this one, and then this one. If we follow it, we visit this one first, then visiting this one means B first, then D. So, B, D. Similarly, visiting this one means C first, C, then visiting this one means E first, E and G and then finally F. So, this way the different thing. So, what I want to say is that if this is the tree that is given to you, then these are the different way the tree can be visited, and each way representing one what is called the encoding form. So, this way it is the tree encoding come into the picture, and it is also some way resembles with the order encoding scheme that we have discussed for the genetic algorithm. Now, so this is the tree encoding scheme, and this is one encoding scheme is there, and next I want to give one example of this tree encoding scheme. This example is basically is a problem. It is called the floor planning problem. So, floor planning problem is basically the idea is that the different what is called the blocks are there. So, these are the input blocks of different sizes, and you have a floor, right, and then you have to arrange all these blocks into this floor, so that there will be no wastage of space, and within the minimum floor area we can place all these blocks into the floor. So, it is basically layout of the floors needs to be decided by placing all the blocks into that floor, so that it takes the minimum area or something else like. Now, this is the one example called the floor planning, and we will see exactly how the tree encoding can be applied to solve this kind of problem. Now, here to be more specific for the problem is concerned, we want to make it little bit complex, so that the problem has takes its own strength like. So, here the input is a set of blocks, n number of blocks, and we assume that all blocks are of rectangular size, and these blocks are denoted as B1, B2 up to Bn. So, these are the n number of blocks are the input to this problem, and for each block there is some specification. The specification is there. For each block it is specified by width and height. That means, if this is a block, it basically width W and height W. So, it is specified, and there is also another specification. So, and then blocks are rigid. Rigid means no way this width and height cannot be changed, and rho I for each block, it basically states the aspect ratio. That means, it is basically decided rho I is this one. So, H I by W I. So, if rho I equals to 1, if the blocks B I is rigid, otherwise it is there. So, we assume that rho I is equals to 1 in this case, and then given that W and H I, we can easily understand our area of the block. So, A I denotes the area of the ith block or block B I. So, this is the specification of the problem at hand, and then we will see exactly how the problem or what is the objective function for this problem is there. Now, here, so there are n number of blocks, and we assume that the blocks are connected from, there is a connection, or we can say line from one, that is, this is basically the problem related to the VLSI problem. It is called the very large scale integration, where we have to place the different circuits. Each circuit resembles to one block, and then there is a input output connection. So, this connection is basically called the net. So, there are n number of connections which is shown here, the set of connections, n is the set of connection, these are the connections. So, the idea is that if B is given there and n is the connection, and f1 is a one objective function, it is known there, by which it can say what is the total wire that is required. Wire means how many connectivities, how many cost of networking is required, and also if rho the aspect ratio is given for each block, and then set of block is given, and then this is the network connection, then what is the area that is required, it is also given by this function f2. Similarly, f3 is another function, it will basically calculate delay of the entire things for so far the circuit is concerned. So, it is given the set of block and then connection, and then rho the aspect ratio, then f3, this will give the measurement about the delay involved in the layout design. So, these are the three functions f1, f2, f3. It is obtained from the VLSI specialist. They given this B and n row or B n row, they will be able to calculate f1, f2 and f3, namely the wire length, the area and the delay of the block that is required. Now, so our objective so far the genetic algorithm is concerned, find a network connection out of the so many networks and from the B, so that this F1 can be minimized, F2 can be minimized and F3 can be minimized. So, it is basically the multiple objectives here, unlike the single objective that we have discussed so far. Now, in this multiple objective we have to minimize 3 objectives: the area, wire length and then circuit delay. So, these are the things defined by the functions, it is already discussed. Now, we will come to the encoding scheme rather. So, how the encoding scheme can be there. Now, before going to the encoding scheme, let us consider 2 instances here. So, these are the different block 1, 2, 3, 4, 5 like this one, and these are the one plan. So, that if it is plain like this. So, for the same set of blocks 2 plan we have mentioned it was, and this is the one plan. So, this is the 2 4 plan are given here, and then we have to see whether for this 4 plan area is minimum or delay is minimum or the length is minimum, whatever it is there. So, basically the idea it is there. Now, given a set of block, can you imagine how many different 4 plans are possible? There are in fact many, that is a okay, and searching for all the 4 plan and then ultimately finding the minimum is a very time consuming problem. So, this can be represented in a GA framework and then finally can be solved using genetic algorithm. Now, so to do this thing we have to do certain encoding scheme. Now, the encoding scheme that we are going to propose, it basically like this. It can be modeled in the form of a binary tree, because we are going to realize it using the tree encoding with n number of what is called the leaf nodes, that means the last node does not have any children, and n minus 1 the non leaf nodes, and each node represents a vertical cut line or it is called the horizontal cut line, and later they can be represented by V and H respectively, and each leaf node represents a rectangular block. So, this is the specification. Now, let us see how the same thing can be represented in the form of a tree given a 4 plan like. So, idea it is like this. Now, here we can see it. So, this is the one 4 plan, and this 4 plan can be represented equivalently in the form of a tree. So, here V basically vertical line. So, it is basically the vertical line, and then there is a one horizontal line. So, it is V, then H, and then 2 and 1. So, this is the leaf node. Similarly, if we come to this part, so this is basically left part of the tree. Now, this is the right part, again from one vertical. So, right part, this is the right part. So, this is the right part. Now, in this right part we first have the horizontal cut. So, this is the one horizontal. So, this H and this 3. So, this is the one, and then again this part. Okay. So, this part again another tree. So, it is represented by this part. So, here one horizontal, this is the horizontal cut, and this horizontal has one vertical. So, it is vertical 4 5 and another vertical 6 7. So, this one. So, idea is that this kind of 4 plan can be represented by means of a tree whose structure is there. Here these are the leaf node represents the block ultimately, and other the non leaf nodes V, H, they are basically whether it is a vertical cut or horizontal cut. So, it is a vertical cut, it is a horizontal cut, the constant. Now, so the idea is that any such 4 plan if it is given you, we can find either equivalently the corresponding tree, and this is the concept of tree encoding in this case. Now, as a few example further, the different 4 plan if it is given to you, we will be able to represent it, and that tree can be represented using the different traversal that we have discussed, in order, post order and pre order. So, specifically one particular order is used, that is called the post order traversal. Post order traversal can be expressed in this form. So, if it is like plus A, B, then divide, then C. So, is A plus B divided by C, this kind of thing. So, it is basically A B plus then C this one. So, it is like that. Okay, so this is the way that can be. So anyway, so some tree representation can be used, and then the one traversal, the post order traversal can be followed, and then it can be obtained. For okay, we can represent one example. It is like this. Here, for example, here say suppose this is the floor plan and this is the equivalent tree. So this tree is a graphical display. This can be also alternatively represent in this form. It is basically called the police notation or the post order traversal. Post order traversal means, so in order to traverse it, first left, then right, and then finally this one. So here for example, so first left means we have to find this one. Now to do things again left, right, this one. So 2 1 H. So further this traversal is concerned. Then we have to traverse it. So to traverse it, first left and this again left. So 6 7 V. So it's 6 7 V corresponds this traversal first. Then this one it is a 4 5 V, and then finally it is H, this one, and then finally we will visit 3 and H. So it is this one and finally the last one. So this way. So this basically, if this is the tree given to us, then it has the equivalent representation which is shown here. So what I want to say is that if this is the floor plan and if this is the tree encoding, then this tree encoding can be compact way represented by this one. So what in other words, it is that this is basically is a encoding scheme for a solution. So this is a solution and this solution is represented in this form, and this is the encoding scheme. And this in fact is a solution, means it is a chromosome. So in this case the length of the chromosome same as the number of nodes involved here. Now the number of nodes can vary if the different order is followed. So obviously it is a variable length chromosome can be obtained if it is like this. Now so the same idea can be extended, and then you can for example, if this is the one layout it is given, then corresponding for your practice you can check it. If this is the one solution, this is the tree and this is the solution representation or encoded form of the solution or a chromosome. So the idea it is there. Now the problem here, okay, our objective is to solve the optimization problem, so that how we have to find the best solution here. Now if so alternatively also, if this is given we can draw the floor plan also. That means if it is given we can do it, or if it is given we can obtain it and then we can obtain the floor plan or directly from the floor plan. So all the representation are basically same, and then same thing can be obtained uniquely. Now so idea here is that this is the one floor plan we have to obtain, then one solution is a tree, that means one representation that can be thought of. That means how many way this representation can be thought of if the n number of nodes are there. So basically the number of solutions are basically how many different tree that can be formed. Now so if it is only fewer number, then no problem, but actually this number is a large number. That means for n number of blocks, the number of trees that is possible which represents one solution is a very large number. So this number is okay. So this is another example. Okay, you can understand whether this is correct or not. This is the tree representation, this is the floor plan, and this is this one. Now the question is that how many number of solutions possible if there is an n number of blocks in a floor. So it is a floor plan with n number of blocks, then how many solutions are there. Now it is very difficult to calculate the number of trees that is possible, and it can be shown that the number that is possible is this one. So this is eventually a very large number for n, where 2n n basically it is it represents 2n n, this is equals to basically combination 2n c n. So this is very large number in fact, and then so it is a large number means we cannot solve in real time. So it require some other approach, or hard programming approach cannot try out all possible trees and then finally finding the optimum tree corresponding to the best floor plan in this case. So the genetic algorithm approach is we have to randomly choose some solutions. Randomly choose solution means whatever the pattern that we have discussed about, that one pattern or one path or one tour, and then decide the solution, and this way we can try out all possible in a random or probabilistic search manner. So, this is the concept of tree encoding that we have discussed about it, and then we will discuss. So, this is the encoding scheme that is followed in genetic algorithm, and we will discuss about other operators. The next operator that we will discuss in the next lecture slide is the selection scheme, that means how to select the best solution out of many solutions are there. So, we will be discussed in the next lecture. Thank you.